Good evening, everyone. Welcome to the session. We'll be continuing with the problem solving session, and we have a few of the questions left out of the permutation, combination, and probability questions. We'll continue that today, and I think today will be the last day for this topic. I hope you are solving questions after going from the sessions. We'll wait for another 20 to 30 seconds for people to join the session and then start the session. We'll start the session. I'll just display the question on the screen. Take 3 minutes to solve the problem. I've started the timer. Time. Please post your answers. There are two responses, one for option D and one for option A. Others, for solving it, please do it quickly and post your answers. So for one has got option D, one has got option A, and now one has got option B. It's 269, 302, and B is 271. So we'll see how to go about this question. People who are solving it, please post your answers. So they are asking the number of times the digit 5 will appear while writing the integers from 1 to 1000. So we'll go in an ordered fashion. They're asking the number of times the digit 5 appears while writing the integers from 1 to 1000. So first, in single digit numbers, how many times it occurs? Only once. That is 5. Only one number, that is 5. This is only once. And then we'll cover double digit numbers. In double digit number, there is this space and this space, two spaces, double digit numbers. So if I keep 5 in the units place, here there can be 9 digits. That is, 0 cannot come here, because if 0 comes, that will become a single digit number. So here in this place, there can be 9 numbers from 1 to 9. So this will be 9 numbers. And then once this is covered, when the units place is covered, we will see the if 5 is there in the hundreds place, how many numbers can come here? So this is 10. If 5 is here, this will be 9. So here 9. So this will be 10. 10, that is 0 to 9. All the single digits can come here. So this will be 10. 0 to 9, that is 10 digits. This is 2 digit numbers. So 2 digit numbers would be 19. And single digit, 19 times 5 would come in 2 digit numbers. In single digit numbers, 5 will come once. Now we'll see 3 digit numbers. First I'll keep it in the tens place. Here 0 cannot come here, so there will be 9. Here all the digits can come. 9 into 10 is 90. 90. Then if I keep 5 here in the hundreds place, here there will be 10 numbers, 10 digits that can come here. Here again only 9 can come because it will become 2 digit number. Again this is 90. And if I keep 5 in the hundreds place, here 10 digits can come, here 10 digits can come. That is 0 to 9, 0 to 9. This is 100. So if I add total here, so 100 plus 90, 190. 100 plus 90, 190. 190 plus 90 is 280. 280 plus 20 is 300. 19 plus 1 is 20. This is 300. Correct answer is option C. No one has got option C. But is this clear? If you have any doubts, please ask. Lohit, Tam, and Shweta, if you have any doubts, please ask. Others, if you have any doubts, you can ask. Don't hesitate. I mean, if you have any doubts, please ask. Tam, is this clear? And Lohit? Okay. We'll move to the next question then, if things are clear. So take 3 minutes to solve the question. time. Please post your answers. One person has got option C. That is 1049. Others, if you are solving it, please solve and post your answers. We try solving it. Try to think how to solve this. Others, Sam. Okay, I'll just explain this question. So a printer numbers the pages of a book starting with 1 and uses 3089 digits in all. So how many pages does the book have? They are saying that this printer uses 3089 digits in total, and they are saying that the book starts printing the numbers from 1. For example, if there is only 2 digits, only 2 pages, 1 and page number 2, the number of digits used is just 2. If there are 3, the number of digits will be 3. So this is nothing but the sum of all the digits that are printed. So if there are page number like 1 to 10, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 digits. If there are 10 pages, there will be 11 digits, total digits. They are saying likewise, so if there are 3089 digits that were totally used, so then how many pages would be there? So indirectly they are asking to find out what are the number of pages, and once you find the number of pages, you have to find the total number of digits. So let me first go by step. We'll see how many digits or single digits that will have single digit page numbers. There will be 9 digits. The number of digits used for printing single digits till 9 is 9. And for 2-digit numbers, that is from 99 to from 10 to 99. From 10 to 99. First, we have to calculate how many digits are there. 2-digit digits, 2-digit numbers. 99 minus 10 plus 1. We had covered a similar problem like this yesterday. This would be 89 plus 1, 90. So since there are 2 digits here, the total number of digits will be into 2. 90 numbers into 2 digits. The total is 180 digits are used. And now we'll see the number of digits in 3-digit numbers. It is from 100 to 999. The total numbers would be 999 minus 100 plus 1. This would be 899 plus 1, that is 900. And the number of digits in each 3-digit numbers is 3. The total digits that are used is 900 into 3 is 2700. 9 3 are 27, 2700. Now till 1000, till 999, the number of digits used would be 2700 plus 180 plus 9 plus 9, 8, 8, 2. 2889 are the number of digits that are used. And they are saying that the printer used total 3089 digits. The difference is 3089 minus 2889 0 0 and 10. If you carry this here, 10 minus 8 is 2. 200 more digits are necessary. So, but these are 4-digit numbers. See, there are 4-digit numbers. So you would have, so if you have total digits is 200, and the total number of 4-digit numbers that you require to get 200 extra digits is 200 divided by 4. This is 50. So you need 50 4-digit numbers to make it total, to make the total 3089. So what would be the 50 digits? So that here similarly from 1000 we need some number, some here, which number we don't know, we'll keep it as x. The total number of digits is x minus 1000 plus 1. So that should be here, that should be 50. That's what we have calculated here. I have divided by 2, so 50. So this, to make it 50, I'll just move this 1001 that side. So this implies x is equal to 50 plus 1000 minus 1 is equal to 1049. So the number of pages that the book has is 1049. I hope this is clear. If you have any doubts, please ask. So if this is 1049, so from 1000 to 1049, the number of pages would be 50. Sorry, number of pages would be 50. And since each page has 4 digits, the total number of pages that would digits that would be contributed here is 200. Now if you add this 200, 2700, 180 and 9, you would get 3089. I hope this is clear. If you have any doubts, please ask. Tam and Lohit, is this clear? If you have any doubts, please ask and let me know at which stage you have any doubt, if you have any doubts. Okay. Lohit? Okay. I hope others also don't have any doubts. If you have, you can ask. Is everything clear? So we'll, if things are clear, we'll move to the next question. Take 3 minutes to solve the problem. Please post your answers. So 4 people have got option C. We'll see how to go about this question here. So what they're asking is, how many integers are there between 1 and 100 which have 4 as a digit but are not divisible by 14? So they are saying that the numbers should have 4 but it should not be divisible by 4. So how many such digits numbers are possible? So we'll go one by one. In single digit, there cannot be 4 here. If only if single digit 4 is there, it will be divisible by 4. In double digits, we'll see, we'll start with 1. So 1, 4 is possible. I mean, this number has 4, but it is not divisible by 4. 14 is not divisible by 4. Next, 24 cannot be the number because 24 is divisible by 4. So then it would be 34. 34 contains 4, but it's not divisible by 4. After that, 44 will be divisible by, this is not divisible by 4. 24 is not divisible by 4. Sorry, it is divisible by 4. 4 is divisible by 4. 34 is not divisible by 4. 14 is not divisible by 4. 44 is divisible by 4. And then after 44, we have 54. 54 is not divisible by 4, but it contains 4. After that, 64 64 is divisible, it's divisible by 4, so this is not included. Then we'll have 74. 74 is contains 4, but it's not divisible by 4. So they are asking what are the numbers which are, how many numbers are there which has 4 but not divisible by 4. 74 and then 84. This is divisible by 4, so this is not included, so we'll not count it here. Then we have 94. That is divisible by, this is not divisible by 4. So these numbers are there. Then we have the numbers that is starting with 41, 40. This 41 is not divisible by 4. 43 is not divisible by 4 because it's an odd number. And 45 also is not divisible by 4. Then in the 40s, we'll see the even numbers now. 42 is not divisible by 4. 46 is not divisible by 4. 47 is not divisible by 4. And 49. This all contains 4, but it's not divisible by 4. These are the numbers that is divisible by 4. If we count it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The correct answer is option C, 12, not option D. People who have got option D, which was the one extra number that you have got? These are the numbers, 12 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Okay. I hope this is clear. If you have any doubts, please ask. Deepti, if you have doubts, please ask. Is this clear, Deepti? And others, if you have any doubts, you can ask. Okay, I hope this is clear. So we'll move to the next question. Take 3 minutes to solve the problem. It's time. Please post your answers. Okay, Karthik, now I was only using the English version because I was anyway explaining it in English. That's why I thought English would be more appropriate. Please post your answers. Two people have got option A, one has got option B. Others, if you're solving, please post it. Now, three people have got option A. So we'll see how to go about this problem. They are saying that how many different sums can be formed with denominations 50, 100, 200, 500 and 2000. There are 5 different types of denomination, 1, 2, 3, 4, 5, taking at least 3 denominations at a time. So you have to take at least 3. So you can take 3 at a time, you can take 4 at a time, or you can take 5 at a time. Because they are saying at least 3, not only 3 at a time. So you can take 3 at a time, 4 at a time, and 5 at a time. And you have to individually calculate how many different sums can be formed. So when you are taking 3 at a time, the formula would be like you are selecting out of 5, you would select 3. That is, you choose 3, so 5C3. And if you are choosing 4 at a time, it's 5C4. If you are choosing 5 at a time, that is 5C5. Here, this would be 5 factorial divided by 3 factorial into 2 factorial is 5 factorial divided by 4 factorial into 1 factorial. This is 5C5 is 1. This is 5 factorial divided by 5 factorial into 0 factorial. 0 factorial is 1. So here this is 5 into 4 divided by into 3 factorial, 2 into 1 into 3 factorial. You cancel this. And the 2 to the 5 to the 10. This is 10. This is 5. 5 into 4 factorial divided by 4 factorial. This is 5. And then this is 1. 5 factorial gets cancelled. This is 1. The total is 10 plus 5 plus 1. 16. There are 16 different sums that can be formed using these explanations. The correct answer is option A. I hope this is clear. So if you have any doubts, please ask. I hope this is clear. If you have any doubts, please ask. Deepthi, is this clear? Is everything clear? Okay. See, they are saying that in this 5 denominations that you have, the 5 denominations 50, 100, 200, 500 and 2000, they're saying if you have to take at least 3 denominations, and they're saying how many different sums can be formed. For example, if you take 3, 50, 10 and 100 and 200, if you add all the 3, 50, 100 and 200, you would have 350. This is one combination. This is one sum. And similarly, you have to choose 3 out of this 5. So if you are choosing 3 out of this 5, there will be total 10 combinations. For example, 50, 10, 100 is one combination. 50, 100 and 500 is one combination. And 50, 100 and 2000 is one combination. Like this, if you do, you would get 10 combinations. Similarly, if you take 4, you would get 50, you would get 5 combinations. So if you leave out one every time, you would get 1 for 5 combinations. For example, 50, 100, 200, 500. This is 1. Now I leave this 50 here, 100, 200, 500 and 2000. But I would not suggest you to write down every like this here, because 16 is like, if it is close to 10 or less than 10, you can just write it down. But if it's more than 15 or 20 or 25, 30, using the formula is better, the concepts. So here, this formula is not, I mean, you are just choosing out of this 5, 3. Then out of the 5, we are choosing 4 notes, 4 types of denominations. And then the last one is out of 5, we are using all the 5 denominations. Time, is this clear? I hope this is clear. If you have any doubts, please ask. Okay. So I hope there is no doubt in this question. If you still have any doubt, please ask. In the meantime, I'll move to the next question. Take 3 minutes to solve the problem. Your answers. People have got option B, option C, option D, and also option A. So there's quite a variety here. We'll see how to go about this question. They're saying that integers are listed from 700 to 1000. In how many integers is the sum of the digits 10? So they're asking in how many integers is the sum, that is the digit sum of the digits is 10. For example, 703 is one number. If you add 7 plus 3, all the digits, 7 plus 0 plus 3, you have 7 plus 0 plus 3, this is equal to 10. 7 plus 0 plus 3 is equal to 10. And like this, how many numbers are possible? So we'll go in the order from the least to the highest. 703. After this, you have 712. Then you would have, this is 7 plus 1, again 7 plus 1 plus 2 is 10. Then you have 721. Then 730. This is one number, 730. So after this, you would not have any other number, because the next numbers that start is 740. That number will be, if you add the digits, it will be more than 10. So we'll then start with 8. 802. 8 plus 2 is 10. 8 plus 0 plus 2 is 10. Then we have 811. 8 plus 1 plus 9, 9 plus 1 is 10. And then 820. So 8 plus 2 is 10. Again, after this, you cannot go to 830s and 840s, because if you add those digits, it will be more than 10. Then we'll have numbers with 9. First number will be 901. After that, 910. After this, we cannot have numbers in 920s, because 920s, 9 plus 2 would become 11. This is the last number. So we just have to add these numbers. 9. There's total 9 numbers whose digits add up to 10, and which is between 700 to 1000. So the numbers are, number of numbers, such numbers would be 9. It is option D. I hope this is clear. So if you have any doubts, please ask. Is this clear? Is the doubt? I mean, people have got option B, option C, and option A. If you have any doubts, please let me know. So if things are clear, this is the last problem of the day. This is also the last problem of this topic, permutation combination probability. So we have come to the end of the maths CSAT topics. So if you have any doubts, you can ask. Tomorrow we'll be having a discussion session or doubt clearing session in Telegram channel. We'll have a live stream where you can verbally ask your doubts. Okay. Others, if you have any doubts, please post your queries here. Else we'll meet tomorrow, that is Sunday at 8 o'clock, for a general discussion on your preparation for people who are writing or taking prelims this year. So we have ordered all the videos topic wise in the playlist. Karthik, give me some time, 1 or 2 days. Uh, we'll see how to go about uh, how to go about the passage. We'll form a session on that. We'll have a session on that. Give us 2 to 3 days for solving passages and critical reasoning. I mean, these two types of verbal problems. Others, if you have any doubts, please ask. So you guys are welcome. I hope these videos were useful. I think there are total now 49 videos of the sessions that we have conducted. Yeah, there are 49. Yes, I mean, don't leave any topic. I mean, there are questions of blood relations in the exam. Don't leave any topic. Solve the topics. I mean, at least go through the basics and solve a few questions on the topic. That will be very helpful. Okay. So all the videos are there in the playlist if you want to watch it. And please continue solving the problems topic wise, and at least solve 20 to 30 questions every day till the prelims. Don't stop solving questions. Solve questions, not just maths, but also logical reasoning and reading comprehension. And the verbal part, I mean, verbal, logical reasoning, and the maths part, all the three sections. Solve around 20 to 30 problems every day. And please time yourself. Keep a timer and solve the problems. So it will take around 1 to 2 hours to solve the problem and see all the solutions and all. Probability, all the previous year's questions are over. It's done. There were around 40 to 42 questions that were there. So we had solved all the problems. So Shweta, if you want, you solve the problems. I mean, you take any book and solve problems. You're not getting confidence in solving the problems. The more you solve, the better it is. I mean, you will get the confidence. Take any book which has topic-wise segregated questions and then solve it. Okay, then we'll end the session here. Tomorrow we'll have a general discussion on Telegram live streaming. We'll meet at 8 o'clock tomorrow. So you can ask if you have any doubts regarding preparation, you can ask there. And we're happy that these videos and these classes were helpful. And please do well. And please don't neglect the CSAT. Solve the problems. I mean, you have to do it. You should have a hands-on experience. You should have solve the problems by hand. Don't just see the solutions and just move on. You have to hold a paper, pencil, and then solve the questions. So there are around 20 days left. So solve at least 30 questions, 20 to 30 questions every day. So that even if you are solving 20 questions, there will be 400 to 500 questions that you have to solve in these days. So solve that. I hope your preparation would be in a much better position. So thanks, and thanks for all the support and all the encouragement that you all have given us. And it's a lot. I mean, it means a lot for us. We wanted to start an initiative where people would really benefit from the initiative, and I hope our efforts are reflected in your results on the day, on May 28th. And once the prelims is done, please let us know how was your exam. We'll have a general discussion on Telegram also after the exam. Please let us know. At least we'll be happy to hear that you have done well. So we'll end the session here. We'll meet tomorrow at 8 o'clock. We'll have a half an hour to 1 hour session. So please, if you have your doubts, please make a list of all your doubts, and you can ask tomorrow. So thanks for coming. I hope these discussions were useful, and we'll be ending this maths session, this year's maths session, CSAT sessions. And we'll give us 2 to 3 days. We'll think of having one session on the verbal part also. We'll conduct one session on the verbal part, or at least to give you the direction of how to go about the CSAT and the verbal part. It is reading comprehension and critical reasoning part. So good night. Have a nice weekend. We'll meet tomorrow at 8 o'clock. We'll have a general discussion. If you have any questions, please make a list of it and you can ask tomorrow. Thanks, and thank you everyone. And once again, thanks for all the support. We have also crossed around 10,000 views and 700 odd subscribers. And there are around 40 to 50 classes that we have conducted from March 8th. And it's a huge support that you have given. Thanks a lot. Good night. Thank you.